Right. We want to look at what binary operation is. Now, looking at the word binary, BI, it implies two. So binary operation describes any operation that involves two elements to produce another element. So in mathematics, the basic operation we know of is addition, subtraction, multiplication, and that of division. Now, in these basic operations, we can carry out different forms using different elements. Now, for this discussion, we will consider our universal sets or our sets to be under the members of real numbers. So our discussion is going to focus on members of real numbers. So any operation that will use two elements to produce another element, which are all members of the real numbers, is said to be a binary operation. So a binary operation, like I said, is an operation which combines two elements. Let's say A and then B, which are all members of the real numbers. Then they operate each other, giving, let's say, an operation, let's say star. So we have A star B giving us, let's say, C, where C is also a member of real numbers. Then we see this is a binary operation, right? So in binary operation, most of the commonest operation signs that are used is this. You can have the star, you can have the R, you can have this way, you can also have this way. Actually, these operation signs are not exhaustive. They are not exhaustive. You can have so many examples. Now, before you can carry out an operation in the binary system, what we do is that every operation that is given is having a rule. It's given a rule which explains how the operation should be carried out. For example, you have A, operation B. The rule should be given where we can have A plus B plus AB. In this case, what we are saying is that to be able to operate any two elements, then we combine the first element, the second element, then we find a product of the two. For example, if you are given, in this case, let's say 2 operation 3. Based on this rule, we will have to write 2 plus 3 plus 2 times 3. So when we add, we have 5 plus 6, and that should give us 11. Right. So anytime you are given a binary operation, it is expected that a rule should be given to be able to evaluate whatever you are asked. In the same sense, if you are asked to evaluate, let's say 5 operation 4, using the rule that has been stated above, then it means that this will be evaluated by 5 plus 4 plus 5 times 4. So when we come down, 5 plus 4 should give us 9, then 5 times 4 should give us 20. So together, we should have 29. Right. So that is just about binary operation. And note that since our set, or since this operation is a closed operation, where the answer that we must get is always in the real number set, then that is why the answer that we get is always a real number. So let's try to evaluate this, assuming an operation star is given us is given by so this operation star is given by A operation B being equal to A plus B minus AB. So let's evaluate these examples. We have 6 operation -3, then we have 5 operation negative. Now, according to the rule, we are told that if you have A operation B, then what we do is that you write the first term plus the second term minus the product of the first and the second term. So since we have 6 operation -3, we are going to have 6 plus -3 minus 6 times -3. So we add the 6 minus 3 giving us 3. Then we have -6 times minus 3. So we have 3 plus what? 18. And that should give us 21. In the second example, we are told that 5 operation -4. So 5 operation -4 is giving us 5 plus -4 minus 5 times -4. So coming down, 5 minus 4 giving us 1. Then 5 times 4 negative product gives us positive, so plus 20. Together we have 21. So this is how binary operation is actually evaluated. Now, in sometimes you are given, let's try this example. We have a binary operation. This form is given by, let's say, m operation n equal to 1 over m plus 1 on n. Right, in that case, we are asked to evaluate these numbers, where we have 3 operation 2. Then we also have 2 operation 3. So continue. Remember, our rule was given by m operation n being equal to 1 on m. Sorry, the operation is okay, so let's change. Our operation was given on m operation n plus 1 on n, and we're told to evaluate 2 operation 3 and then 3 operation 2. So happen 2 operation 3 is to be giving us 1 on 2 plus 1 on 3. Add the 2 means you're gonna have 5 on 6. Then 3 operation 2 should give us 1 on 3 plus 1 on 2, same giving us 5 on 6. Right. So basically that is it about operation, binary operation. This is the introductory aspect. Stay tuned for more examples. Thank you.